Okay, before we start, I want to show everyone where these videos can be found so that I don't have to keep emailing you. Remember that the site itself is bookmarked, or should be bookmarked, in whatever web browser you use. So if I go to our class website and you see the calendar, go to Homework Calendar, which is also a calendar that you can put on your phone or put on your computer or put on your iPad or whatever. If you go to today's date, today when I recorded this was Wednesday, January 9th. If I click and open this, I'm actually going to see two videos. One is the video that you should have watched for today, and I kind of keep that grouped with all the notes and all the homework that we start today. And the other is this video that you should be watching tonight that I'm recording this, which would be last night, January 9th. So I'm going to post tonight's video, which is going to be for 4.5 in two places. I'm going to put it tomorrow so that you can see it, and then I'm going to put it Friday also so that it's grouped together with the notes that it's actually for. So this video I'm recording tonight is actually for Friday 4.5. So the purpose of today, to multiply a polynomial by a monomial, and the whole key to this is the distributive property. We said that there's the distributive property of plus and minus, or sorry, of multiplication division over addition subtraction. And if I start launching into some examples, well, hang on, one more thing before we kind of launch into examples. Remember, a polynomial, more than one term, joined by plus minus, and a monomial, we can just say for right now is just one term. So if I look to number one, we've done these before. This is just distributive property, taking the negative 6 and multiplying it in. This would be negative 6x plus 12. And number two, we've done things like this before, just not quite like this, still distributing. 3xy multiplies by x to become 3x squared y, and 3xy multiplies by the negative 2 to become negative 6xy. Because these are different, the same variable, but to different exponents, we can't add those. Those are not like terms. So this problem is pretty much done. I'm going to kill those underlines. Continuing on, we now have a monomial multiplied by a trinomial. So 4xy multiplies by the y squared, then it's going to multiply by the negative 2y, then it's going to multiply by the 1. 4y squared times y squared is 4y to the fourth power. 4y squared times negative 2y is negative 8y to the third, and 4y squared times 1 is 4y squared. Again, no like terms, so that can't be simplified, and that's done. The next one, I'm going to multiply it to each of these three parts. Keep track of what's going on. 2 times 5 is 10. X squared times x cubed is x to the fifth, and leaving us a y. The next part, minus 6. X squared times x is x cubed. Y times y is y squared. And 2x squared, y times y squared is y to the third. Don't worry so much about order. I'm going to keep them in the order that they were, but we're going to learn a little bit later about descending order, particularly with the x's. You want the x's to be of descending power. Number 5, we have the 1/2 s squared t is our monomial. That is going to get multiplied by each of the three terms in the trinomial that follows. So again, distributive property. 1/2 times 4 is 2. S squared, just s squared, and then t times t squared is t cubed. Minus 5 s cubed t squared plus 3 s to the fourth t. Multiplication here, we got two distributive properties going on. Those multiply to become 15x minus 6x squared. Then we have plus 6x squared minus 12x. Now we've got some like terms that we can add. The 15x and the 12x can add to become 3x. And the negative 6x squared plus 6x squared drop out because they add to become 0. So we're just left with 3x. Flip the page around to the back. We have some grouping symbols within grouping symbols, so we have to follow the order of operations. I'm going to keep this as 8n minus 2 with a giant set of parentheses around what's going on here. If I look at that, I have to actually distribute the negative 2 before I can worry about that n minus part. So I've got the negative 2 times 3, it's negative 6, and negative 2 times negative n, which is positive 2n. I'm going to do one more step and simplify within those parentheses following the order of operations. 3n minus 6. Now I'm going to distribute the negative 2. 8n minus 6n plus 12. 8n minus 6n is 2n plus 12. Those are not like terms. Circle it and you're done. Remember, you can pause at any time in this video to kind of catch up. So I just don't want to make these too long. Next step, or next one, 2x. We have this giant grouping symbol here, so I'm going to kind of copy that with bigger ones. I tend to not like brackets, as you know. I just kind of like bigger and smaller parentheses. But 3x minus 6 minus 2x. Watch that negative in distributing the negative 2. Still have the minus x squared, and it's absolutely correct to copy that x squared down on the next line because you want every line to be the same as the one that came before it. All I'm going to do in the next step is simplify within the parentheses. 3x minus 2x is x minus 6, then minus x squared. Now we're going to distribute the 2x squared minus 12x, then minus another x squared. Like terms get added. 2x squared minus x gives us an x squared. Still have the minus 12x, and now we're done. Number 9, 3/4 times 8 is 8 divided by 4, but then times 3, so that's 6. 6x. Then 3/4 times 2 is going to be, well, if we do it off to the side here, 3/4 times 2 over 1, cancel, and I get 3/2. So minus 3/2 x squared. Then I'm going to have minus 1/6 of 24 is 24 divided by 6, or 4. Plus, watch the negative. Remember, there's a negative 1/6 here. 1/6 times 9 is 9/6, or 3/2 x squared. 6x minus 4x is 2x. And the negative 3x and the positive 3/2 x squareds cancel out. So those are our simplifies. With simplify, we never put inside set notation. We just make sure that every line is the same as the one that came before it. Next ones we're going to go to are the solves. Solves, we're thinking set notation. Set notation is putting our answers inside braces. Just kind of refreshing you that from last semester. We're going to simplify the left and then simplify the right as much as possible before moving stuff around. So 4y minus 28 minus 2y plus 6y squared equals 6y squared. I'm still going to simplify the left and simplify the right, so I'm actually going to put these in descending order because I prefer that. 6y squared is going to go first, plus 2y because the 4y and the negative 2y add to become 2y, and then minus 28 is equal to 6y squared. Well, you can see that if we subtract 6y squared from both sides, that those drop out. So I'm left with 2y minus 28 is equal to 0. Add 28 to both sides, and you get 2y is equal to 28. Divide both sides by 2, and we have y is equal to 14. I'm going to put that in set notation for my final. Number 11, it's 1 on the left side, so no simplification there. I'm just going to write 1 equals, then 2x squared minus 4x minus, okay, I've got to put the big parentheses here and work our way from the inside, so I'm still going to have 5 minus, but then 2x is going to distribute there, and then negative 2x times x, or negative x is positive 2x squared. Now I'm going to keep going with this right side. We have to distribute this negative 1 to all three of those. So I have 2x squared minus 4x minus 5 plus 2x minus 2x squared. Add like terms. The 2x minus x squared, 2x squared drops out. The negative 4x and the positive 2x become negative 2x, negative 5. Still 1 equals. Let's add 5 to both sides, and I get 6 equals negative 2x. Divide both sides by negative 2, and x is equal to negative 3. Brace, brace. Find the area of the shaded region. Whenever we find areas of shaded region like this, it's always whole minus part. So the whole area is 4x times 5x plus 3. Remember, the area of a rectangle is length times width. The part, which in this case means the unshaded, is x times 6x. So my entire expression for area is going to be 4x times 5x plus 3 minus x times 6x. Clean that up and we have 20x squared plus 12x minus 6x squared. Add your like terms and I have 14x squared plus 12x. And that's as simple as it can go, so that's our final area. Lastly, surface area and volume. Surface area, as you saw from the homework yesterday, was the area of basically add all faces. So we have to account for every single face we see and every single face we don't see in this. Let's do that first before we worry about volume. I'm going to do this one in blue, and then I'm going to do volume in a different color. In fact, I'm going to do surface area over here on the left so I can save some space. Well, the surface area, we could start with this face here. That face has actually two pieces almost. I can kind of cut it here and make this piece here become a height of, looks like that's the whole thing here is 6x. So if that entire height is 6x, and then this piece right here was 4x, this should be 2x. This is a strategy in terms of labeling all the sides wherever we see them, so we can kind of keep this straight. That's 2x, this is 3x, this is 5x. The base down here at the bottom has to be a 5x plus a 2x, so the whole thing would be a 7x. You can see the 5x piece here, and then the 2x piece there. Makes the whole thing become 7x. And we know that that's 4x, and we know that this is 3x because that's 3x, and that's 3x, and they're all 3x's up there. So once you've got the whole thing labeled, it's less tricky to do because then you're not trying to figure out what all the stuff is. You know what, just kidding, I'm going to switch colors and do this in green. And then I'll do the volume in another color. So surface area, I'm going to split this here. So this piece right here would be 7x times 4x, and that's going to be a 28x squared. So I'm going to tally them over here. I have this funky, well, let's not draw it like that. Let's just go 28x squared plus, and then I have this little piece here that's a 4x squared. 4x squared. And then I have two of those because I have one on the back. So that takes care of that face. Another face that we have is going to be the face that is the base of the thing. That thing's sitting on a ground, and it's sitting on a ground of 7x times 3x, or 21x squared. There's only one base at the bottom, so I'm going to start adding 21x squared. Okay, so we've got the base. Now let's work our way up the sides. Let's start here on the left. That's a 12x squared. This next one's a 15x squared, then a 6x squared, then another 6x squared, and then we have this piece here, the last one remaining, 6x times 3x, or 18x squared. We've already added up everything else on this figure, so we've got to just kind of put all these in there. So I'm going to say plus 12x squared, 15x squared, 6x squared, 6x squared, and 18x squared. So all of these have to add up. Now, if you think about it, is it necessary to write the x squared every time? No. because they're all like terms, we're going to have an x squared at the end. So let's kind of see what's happening here. 28 plus 4 is 32, times 2 is 64. So we have 64 plus 21 plus 12 is 33, 43, 48, 54, 60, 78. So that should be 60 plus 78 x squared. My final sum should be 142 x squared for the area. So that answers area. Okay, now we have to worry about volume. Volume is defined as, let me switch to red here. Good. Volume is defined as length times width times height. And what I would do for volume with this, and you have to think in 3 dimensions here, I'm going to erase all the green marks because those were area markers. And I'm going to split this entire object into just 2 pieces. This is going to be a little bit of a trick in the brain to see if you can see how I'm cutting this thing up. But I'm going to do it like this. This is not the choice you have to make. There are other choices in terms of how you can do that. But if you can see that now as 2 rectangular prisms joined together, then this becomes a lot easier. Because for the piece on the right, I can say that the length is 3x, the width is 2x, and the height is 6x. So my first volume, we'll call that volume 1, is 6 times 3, 18, times 2 is 26, or 36, and then x times x times x is x to the 3rd power. My second volume comes from the one on the left. We'll call that volume 2. That has a length of, really doesn't matter which one we pick, but let's say 3x. I'll do it up at top here since that seems to be a little bit easier. There's one, there's the other, and then its height is 4x. So 4 times 3 times 5 is 60. So that's a 60x cubed. Add them up, and I get 96x to the 3rd power. That's volume. So volume equals that. In the short term for surface area is really just to put SA. Surface area is equal to 142x squared. Notice how the area is a square, but the volume is a cube. That's really important later. And that's it.